Direct and inverse variation. Okay, on direct and inverse variation, the main thing you need to know are the two formulas. So if you see something that says varies directly, you know you're going to have an equation that's pretty much in a straight line like this one. So this says y varies directly as the nth power of x. So your formula will be y equals k times x to the nth power. That's the nth power of x that we see here, this x to the n. The k is just a constant. It's what we call our constant of, I call it constant of variation, and they call it the constant of proportionality. So it has many names, I guess. And y is just another variable in your equation. Okay? So look at the second one. It says y varies inversely as the nth power of x. So it's inversely proportional. That means you're going to have an equation with a fraction in it. Y is varying inversely to x. That's why x is in the denominator this time. You can say that it is inversely proportional. Okay, so if it varies directly, it's in a straight line, everything's multiplied together, and if it is varying inversely, you're going to have a fraction where your y is pretty much in the numerator and your x is in the denominator. So let's look at an example. The gravitational force between an object and the earth is inversely proportional to the square of the distance from the object to the center of the earth. If an astronaut weighs 205 pounds on the surface of the earth, what will he weigh 180 miles above the earth? Assume that the radius of the earth is 4,000 miles. Okay, well, the first thing we need to do is come up with our equation. And usually you will need to calculate your k, or your constant. And that's exactly what we're going to have to do here. And there are a couple of things that you might not know in this particular problem that you need to know. For example, the gravitational force between an object and the earth is the same as that object's weight. Okay, it's how hard the gravity is pulling on a specific object, and in this case it's an astronaut. So let's just let W equal the weight, and just so you'll remember, that's the same thing as the gravitational force between an object and the earth. Okay, so now we know what W is. And it says it's inversely proportional to the square of the distance from the object to the center of the earth. Okay, they tell us that the radius of the earth is 4,000 miles. Remember, radius goes from the center out. So pretty much if you're standing here, then you are 4,000 miles from the center of the earth. Okay, so the next thing that we need to do is determine the distance. Distance pretty much to the center of the earth. And it says that it is inversely proportional, so that means we're going to be using this formula. So instead of y, we're going to have W. W varies inversely, it is inversely proportional. So we know we have this, we know the k is in the numerator, to the square of the distance. Here's the distance, and here's the distance squared. The square of the distance from the object to the center of the earth. Well, if we wanted to calculate k, we need to solve this formula for k. If we were to multiply both sides by d squared, we would solve this for k. So we would have k is equal to d squared times w, or w times d squared, either way. So let's plug in what we know. K is equal to the distance squared. Well, the distance is 4,000 miles. Times the weight. Well, when he's 4,000 miles from the center of the Earth, he's actually on the Earth. That means he is 205 pounds on the surface of the Earth. When you multiply all of these out, you're going to get a scientific notation number. You get 3.28 times 10 to the 9th power. Now keep in mind this number is already rounded, so when we use our next formula, we may want to go back to this line and use this for K instead of this one. That'll just make sure we don't estimate incorrectly. Okay, so now that we know K, keep in mind this is your K, or this one, whichever one you feel like you need to use. If I were you, I would use the one that we did not round. Now that we know K, we need to figure out the rest of this problem. If an astronaut weighs 205 pounds on the surface of the Earth, what will he weigh 180 miles above the Earth? Well, if he's standing here when he's on the Earth, my dot doesn't want to stay. This is 4,000 miles. Well, if he's another 180 miles above the Earth, then he's standing here. Actually, he may not be standing, right? Then it's the 4,000 plus the 180. So he will be 4,000, you can't see that, can you? 4,180 miles from the center of the Earth. So we're going to have, what are we looking for? What will he weigh? So we're looking for W. W is equal to K, which we discovered was this number. I'll go ahead and write it in this form. K over X to the N. What was X? Well, in this case, it's our D. The distance from the center of the Earth is this 4,180 miles. And that is also squared. So plug that into your calculator and you end up with this number. 187.72 pounds. This is how much he would weigh if he was 180 miles from the Earth's surface, or above the Earth. Okay, how about this one? Hooke's law says that the force exerted by a spring in a spring scale varies directly with the distance that the spring is stretched. If a 7-pound mass is suspended on a spring scale, stretches the spring 4 inches, how far will a 15-pound mass stretch it? Okay, let's go back to this previous screen really fast. Before we do that, look right here. It says varies directly. That would be this formula. Y equals K times X to the N. So let's write this in here. So this is going to be the general formula that we're going to use. In this formula, what will Y and X be? Hooke's law says that the force exerted by the spring varies directly with the distance. So we're looking at force and distance. That will be force and distance. So let's say F equals force. And if you want, you could say that's the same thing as Y in this formula. And we could just use X for distance, or you can use D, whatever you like. So X equals the distance that the spring is stretched. Okay, so let's see. It says it varies directly, so we have that formula here. So F equals K times X to the N. Well, force exerted by the spring varies directly with the distance the spring is stretched. It didn't say anything about an exponent, right? So I think maybe we don't need this little variable right here. Ooh, it won't let me delete just that one. Here we go. Let's get rid of that. There we go. It just says it varies directly with the distance. It didn't say the square of the distance or the cube of the distance, so we don't have any exponent on this x. The next sentence tells us how to calculate k. If a 7-pound mass is suspended on a spring scale, stretches the spring 4 inches. So we know that the 7-pound mass, 7 pounds is the force that's being exerted. So 7 is equal to k times x. The distance that it stretched was 4 inches. So if you solve this for k, you just divide both sides by 4, so you get k is equal to 7/4. So now we know k. We can calculate how far will a 7-pound mass stretch it. Sorry, 15-pound mass stretch it. So the force will be 15. K is going to be 7/4, and we don't know the distance that it is being stretched. So to get rid of the 7/4, we need to multiply both sides by 4/7. We need to use the reciprocal of that fraction to get rid of it. So these all reduce to 1, and we get x is equal to something. Well, 4/7 times 15 is 60/7. Not really sure what that means, so let me pull out my calculator here. 60 divided by 7 is 8.6. Now that would be 8.6 what? 8.6, how far will a 15-pound mass stretch it? So 8.6 inches. Okay, last page. For the following phrases, enter the general formula that applies in the blank. Y varies directly as the nth power of x. Y varies directly, so I have a straight line, as the nth power of x. So we have our constant and our nth power of x. Y varies inversely as the nth power of x. So y equals, this time we have an inverse proportion. Y varies inversely, so here's our constant, as the nth power of